Niacin, once a humble vitamin B3 molecule primarily known for its role in preventing pellagra and managing cholesterol, has found itself in the middle of a far more controversial biochemical battleground: cancer metabolism. The twist? Depending on the context, niacin can be both a metabolic ally in protecting healthy cells during chemotherapy and a potential accomplice in tumor survival. In the high-stakes world of oncology, this duality raises a pressing question: is niacin a friend or foe when it comes to cancer? To understand niacin's paradoxical role, we need to dive into its metabolic function. Niacin is a precursor to NAD, nicotinamide adenine dinucleotide, the master coenzyme involved in hundreds of redox reactions across all cells.
NAT
Fuels energy production in the mitochondria, supports DNA repair via enzymes like PARPs, and acts as a substrate for sirtuins, which regulate gene expression and inflammation. These are all good things if you're a healthy cell. But if you're a cancer cell, you want NAD? Even more. In fact, you'll go to great lengths to steal it, make it, or hoard it. Cancer cells are metabolically ravenous. They burn through glucose at high rates, the Warburg effect, rely on glutamine and lipid metabolism for growth, and often upregulate NAD salvage pathways to support their rapid proliferation. One of the key enzymes in this salvage loop is NAMPT, nicotinamide phosphorybosal transferase, which recycles niacinamide, a form of niacin, back into NAD. Many aggressive cancers like pancreatic, breast, and colon overexpress NAMPT to feed their addiction to NAD, and they become dependent on this pathway for survival. Here's where things get tricky. Supplying extra niacin through diet or supplements could, in theory, amplify NAD availability, giving tumors the fuel they crave. Some preclinical studies have shown that high levels of niacin or its derivatives may support tumor cell growth, particularly in cancers with upregulated NAD salvage pathways. That makes niacin look like the unintentional sidekick in a heist movie, helping the villain by handing over the keys to the vault. And it's a big but, context is everything. In other situations, niacin can play a protective, even therapeutic role. For one, niacin is crucial for maintaining mitochondrial health in non-cancerous cells, especially under stress. During chemotherapy or radiation, when normal tissues are exposed to oxidative damage and DNA breaks, niacin-derived NAD is essential for activating PARPs and sirtuins that orchestrate repair. In this light, niacin may shield healthy cells from collateral damage without necessarily aiding the tumor, especially if that tumor is already saturated with NAD or reliant on alternative biosynthetic pathways. Even more interesting, inhibiting the NAD salvage pathway, e.g., by targeting NAMPT, is now a therapeutic strategy in oncology. Drugs like FK866, a NAMPT inhibitor, are designed to starve cancer cells of NAD, inducing energetic collapse and cell death. But here's the catch. These inhibitors can also harm healthy cells unless they're supported with selective niacin supplementation that bypasses the blocked pathway. For example, supplying nicotinic acid instead of nicotinamide can restore NAD in normal cells via the Price-Handler pathway, which cancer cells often lack. This creates a fascinating therapeutic window. You knock out the tumor's NAD engine while still rescuing normal tissues. That's not theoretical, it's happening in labs now, and it underscores how niacin can be a friend to the host and a foe to the tumor if used with precision. Still, it's not all smooth sailing. Some tumors may retain multiple NAD synthesis routes, including the Price-Handler and de novo tryptophan pathways, meaning they could escape therapeutic targeting and still benefit from any available niacin. Additionally, niacin's role in modulating immune function, such as its influence on macrophage polarization and T-cell activity, adds another layer of complexity. Depending on timing and dose, niacin might support anti-tumor immunity or dampen it. So, where does this leave us? Niacin is neither purely friend nor foe in cancer. It's a metabolic lever, one that can be pushed in different directions depending on the tumor's genotype, the host's physiology, and the therapeutic context. Broad supplementation without understanding the tumor's NAD dependencies could backfire. But targeted use, especially in combination with NAMPT inhibitors, chemotherapy, or radiotherapy, holds enormous promise for selective protection and synergistic treatment. In the future, we may see personalized cancer regimens that map out a tumor's NAD synthesis profile, and adjust niacin intake accordingly, downregulating in aggressive salvage-dependent cancers, upregulating during recovery phases to rebuild healthy tissue. Until then, caution and nuance are key. Niacin isn't just a vitamin anymore. In the war against cancer, it's a resource, and who controls that resource may decide the outcome.